type of the data. So you need to convert them or calculate the photo distance and following the instruction somehow. So it's very troublesome. But anyway, I mean, the TSP problem we are dealing with is so simple. The distance is simply calculated from equidistant distance. So the formulation is right here. So the goal for this automation problem is that we try to minimize the routing distance, start from the first city up to the last city, and then go back to the original city. So this one should be the objective value. So in your application, you should provide this function, right? Calculate the total distance. I mean, for the SEO solver anyway. Okay, so z, the variable, the solution is integer, right? And actually, it's a permutation. Sequence, right? So every city should appear only once, exactly once, and within this list. So as I mentioned before, the TSP benchmark has a standard format. So this is an example. So we have text file, and we have title, names, ATT48. That should be the capital cities of the 48 states in the United States. And there's a comment. Well, comment is a textual type TSP. Probably you might have a vehicle routing problem. Anyway, dimension, which means that city. Age, weight, type, ATD. Well, you need to check the format to understand what these properties means. So as you can see, this benchmark provides the coordinate. So know the coordinate section. City 1, that should be X coordinate, Y coordinate, like that. So there is a end of file mark in the last line, EOF. So you need to check the file format description in order to read the raw data from the benchmark file. Okay, so that is the format. Then we will check that. And in addition to this problem, there is another file if the problem has a global solution found. And then the benchmark will provide another file for this problem, illustrating the shortest route anyway. So the ultimate solution to the TSP benchmark in extended file. The extension file is called OPT, opt.tool. Okay. So, but within this benchmark, the indexing start always start from 1 to n. Okay. So, but as we know, our C family related programming language, we always start indexing starting from 0. So you need to convert it somehow. If you read directly from this benchmark file. So for the ultimate solution, this file, the content of this file example is right here. So name ATT48, the file name is ATT48.opt.tool. So ultimate solution for this tool dimension, tool section. So as you can see, 1A, so that means city 1, next city should be city 8 up to city 38. Minus 1 is a flag, showing that well it's end of this route. So you have another mark. So you can check the wiki and the TSP library to check out the benchmark file directly from there. Okay, so let us take a look at the what I give to you. Check the list for this. We have a assignment instruction, right? So this is instruction, and the most important thing is the DLS. DLS, this is the dynamic language library I have prepared for you. So it's called TSP benchmark.dll. Later on, I will show you how to use it. Okay, in addition to that, you have demo file, demo application, TSP. In addition to DLL, there is another folder called TSP Bank. So these are the original benchmark file, TSP benchmark file. So for example, let's take a look at this ATT48.tsp. You can use notebook or WordPad to read it. So if I open a notebook and then grab it in this ATT48, it's not good at all because I think the end of the line stuff will be very troublesome for notebook. Let me show the content in WordPad. WordPad, where is it? Okay, WordPad. So if you show the content of a benchmark file and whatever, it looks like the format looks like this one. Name, okay, title, comment, type, as I mentioned before. So you get 48 cities coordinates right here in this section, up to 48 file. So that's the problem. This benchmark does not provide any form2 distance. So you need to calculate the form2 distance from this coordinate by yourself. Okay, so that is the raw data of a benchmark file. So in addition to that, there is if the optimal solution has been found, you will see another file, 8848.obd.2. Take a look at this content. You see, this is the best route. So that means the shortest route, 18 up to what? Up to 69. That's it. So either way, you can directly explore the file format and reading the data by yourself, or use the DLL I provide to you. Okay, so later on we'll show that. And in addition to the DLL and the benchmark, I also give you a demo file, demo application right here, demo application. So demo execution, as you can see, this execution file will use the TS benchmark file DLL I have given you today, and then you can include your own GL library. Try to solve TSP by yourself. Okay, I'm not asking you to do that, but if you did this, you will get a high score anyway. All right, so let me show you the demo application. So this is demo application I give it to you. So we can read in different benchmark problem. So open TSP. So let us navigate to the TSP bank. Right? So basically, this functionality is to read in the benchmark file and then convert it into an objects specified by the DLL anyway. So let us open this ATT48. So as you can see, once we read in the benchmark file, we have comment showing up right here, right? It's kind of right. So I kind of arrange the information from this benchmark, ATT48, number 1348. Shortest length has been known. So global optima has been found anyway. How about this graph? This graph is just a panel, right? So if you provide a panel, my DLL can draw the location of these cities for you, and also the optimal solution. Optimal solution has been drawn in gray color. So actually, there is a optimal route depicted in the gray line. What about the red line? Red line is one solution provided by you. So by default, we have a solution ready there. I think this solution is generated from grading method. So definitely, if you see two line segment close, definitely this solution is not optimal solution at all. Okay, so there is a common sense answer for this problem. If you draw out the route, if any two segment has an intersection, then it is not a global optima anyway. So once we read in the problem, you can use different kind of multi-heuristic algorithm to solve it, right? So this is the ACO method. How about GA method? You can implement that because you have finished the permutation GA, right? So you can directly use that to solve the TSP problem. Okay. All right. So if we use general GA, so we create similar, right? We create GA solver, right? So this one you has completed, right? Crossover rate, crossover type, partial map. So again, user can select another crossover type, limitation 200, limitation rate. So okay, I use GA solver to solve the TSP problem. Reset, right? Execution one iteration. So this is the initial solution. It's really bad, right? So we have observed value 45,000, but the minimum should be 10,000 only. So what are the one iteration, which is similar to the GS solver, right? So we always monitoring these three lines: iteration best, iteration average, and so on the best. the structure is almost the same. The next execution, next iteration, and iteration run to end. So that's related to run to end. So if best solution is updated, then the lines have updated. So again, it's not a global demand, right? So you can see there are still line equals over there. So user might try, well, if I employ 10 ends, right, to see if the solution is improved, reset, run to end. So you can compare, user can compare the shortest length of 10 liter. So right now it's kind of close, right? It's kind of close. 10,000, 10,000, 11,000, 11,000, 10,000. It's close anyway. Remember that, I mean, meta-user algorithm is not going to get a global optima at all. It is, the algorithm will try to get a solution near optima. So unless the problem is so simple, then global optima can be obtained, right? So this is the GA. So GA actually is not good at all for solving this permutation problem or sequencing problem. If we use ACO, so right now it's similar ACO. So ACO do have a pheromone value, right? And if we like, we still can display this starting problem, writing information right here. So create ACO solver. What kind of parameter can let the user specify? Let's show. Drop multiplier. Well, it's for ASSN, I think. Evaporation rate 0.01. Heuristic power factor 3. Initial pheromone value. So initially, pheromone values are all equal to this value. Pheromone drop amount, so 0.001 is quite small anyway. Perform drop mode. Well, I think this is the original version that I have written before, long times before. So what kind of option we have? So far the best only, all ends. Well, you can implement all ends anyway. Pheromone factor, power is 1. Population size, 40 ends will be deployed. Execution iteration limit is 500. So you can, design your own ACO solver. Follow the same, following the same property requirement anyway. So we reset it, right? And then we execute the run to one iteration. So similar, it's ACO method. So actually, each end will try to construct a solution, right? And then so we compare the performance of all these ends, and then the better solution update pheromone matrix. So this is the best solution in the first iteration. Next iteration. So we keep updating so far the best solution in this way. So we let it run to the end. Okay, this is the best solution we can achieve. As you can see, it is still not the global optimus, right? So remember that 48 is a complicated problem too somehow, even though the size is small. Okay, so let us open another TSP. For example, it's a regular one. Let me show you. Circle 60. Okay. Wow, regrading method has been found, so it's not good. Reset. So this is initial solution. And second step, a global optimum has reached. How about the GA method? We can try to generate GA, reset, one iteration. See, that is the way GA. Well, actually, we can say that GA is a canonical approach. Canonical doesn't mean what? GA simply generate a solution, feasible solution for you. GA does not refer any heuristic information. So the performance for GA to solve TSP is definitely inferior, and it's worse than the ACO. ACO should be the best method to solve permutation problem. So you are not going to expect that GA can get a better solution for you. So one iteration. That is the GA solution founding procedure for the GA in solving a permutation problem. So this is the final solution obtained from GA solver. Even though that is a trivial automation problem, okay, but GA cannot get it. And ACO usually you can get it using this initial solution, right? So we reset 1 to n. So eventually ACO can get the full optima somehow using for this problem. And again, for some small problem, if you use small problem, for example, circle 15, just 15 city, it's a small problem, right? So for small problem, you can try some other way. For example, brute force method, right? You can try your brute force method. Oh, probably some problem from dynamic programming. So what I'm going to show up here is that you have a different kind of option to solve this problem. Dynamic problem can deal with small size problem quickly. It's okay. It's 1 city, 1 to n. Alright, this is the procedure of dynamic programming in solving the TC, but I did not show the route anyway. So what we get is 62.77. So it's global optima, right? Global. The sequence should be continuous. So 0, 14, so 13, 13, so it's global optima. So dynamic programming can solve TSP for small problem. It's okay, but for large problem, probably it's similar to the brute force method. If the dimension is large, more than 10 or 20, then it will use up all the memory for the dynamic problem. And we have another algorithm called branch and bound problems. Again, they are similar and somehow similar to the brute force method, but they tend to use more memory to keep tracing to efficiently traverse all the possible solutions somehow. So brute force or dynamic programming, actually that we call that hard computing method anyway somehow. So they try to search efficiently, to search the solution space efficiently somehow. Don't waste time to search those branches without any improvement anyway somehow. But they can only solve small problems somehow. Okay, they cannot deal with large problem too either. So our meta-heuristic algorithm can solve this kind of sequence problem, for example, TC problem, especially end calling automation method is very powerful for solving sequential automation problem. So that is the one we try to implement anyway. All right, so I will show you how to use that DL in order to redeem the benchmark problem, right? So similarly, you need to prepare this user interface somehow. So we will have button open, and then we will have a panel to show the current the city locate the cities and the route we generate somehow. Okay, so we start from our user interface. Okay, and then I will show you how to include how to use this DLL file. So we add a project. C# desktop, not library. Okay, so we directly use WinForm application. Make sure it's appearing in the desktop. Assignment 10. Alright, so we have phone 1 serve as the user interface. So we have to change it. So we prepare the preliminary interface for us. So probably we will have menu strip, right? We have tool strip. We have status strip in order to show extra information for the user. And in the middle of the client area, we like to have a split container. And I don't know, I mean, the user interface is up to you. You need to prepare a decent and pretty or whatever. That's up to you. So probably split container. I have another one here. So if I intend to let this split container to the panel one to display the dot and the city right here. So make sure that is your target. Okay, so I have either way here I have a button, and initially I will show the name. You guys should grab anyway a meaningful icon from the internet. Okay, it's just a trivial thing, but that will make your application look professional anyway. So don't just look at this mountain and the sun's picture appear here. I mean, try to change the image to a meaningful one. TSP tool strip button, TSP open, right? In text, open. Meaning what? Meaning there will be the dialog pop out for the user. Okay. In the display mode, display style, not just image, because image meaning nothing. We like to show the image and text too. How about the menu? It's related to file, right? So we have categories called file or files anyway. You know, under file there is open command. See, similar. So later on you can try. Well, we still can add an icon right here, a small icon right here. So this is an object, so we need to have TSP tool strip, menu strip, button, open. Right? So I will subscribe an event called create event, right? So I call open TSP. I name this event handler function by myself. I'm not going to let the visual specify the name for me. So I specify by myself, open TSP. Some data I will make this button subscribe the same function, this open. Subscribe the same function. So both items will, once both items are quick, they will go to the same function anyway. It's open. Alright, so it's already there. So it's about the time we rearrange our data file somehow. So R right here, assignment 10, right? So R, this is your solution folder. So this is the project folder, right? So drag in the DL, this folder to here. Drag in the TSP bank file here. So later on, all the file, input file, sample file, and the DL is already within this solution folder. So it's much better for you. So probably later on you will have your own graphics resource too. Graphics somehow. Yeah. For example, okay, it's about the time I ask you to do a decent application development. So you can find open file icon. Get a picture anyway from internet to see which one is should you better. Some of them you should pay it, but some of them is free. So save image. Can I save as an image file? So navigate to your graphics directory. what is this kind of JPG, right? That. So we rename it open JPG. Will that be okay? I don't know. So display it. It's okay. Open. All right, it's open. Okay, so once you have graph resource, you can specify these graphs on your button. So see, it's all open there. Property, say image. Okay, in fact, this so-called image regarded as a resource, and resource can be embedded with your executable file. So we are not going to use so-called resource file. We directly import from the original file. Import. So navigate to your graphics directory. This kind, your graphics. So open JPG. So right now you have icon associated with your tool button, but it looks small, right? It's not so sharp at all. So again, you can change it. So click on this toolbar. There is a property called image size scaling, right? So initially the file, the resolution is very high, so it has been reduced to 16 by 16. It looks small. So actually, you can use the large one, 32 by 32, or a medium one. Medium one should be 24 by 24. All right, nothing changed, right? So it's okay because the width has been specified within the size, right? So size height is 25. So in this case, since it's 32, so probably make it 36. Okay, it's look much better anyway. But again, since this figure is not transparent, it's not transparent at all. So you can see there's a white background there. So later on I will show you. If I have time, I will show you how to remove that later. All right, so we have button ready there, right? Double click it. So go to this event handler function. So how can we use it? So your project intended to use the library I provided to you. So the first thing is that within this project, the references you need to edit it, just like the teacher we have done it before. So reference, right click, add references. So browse. Again, navigate to your solution folder, then DLLS. Right here, and click on this DLL file. So we add this dynamic library to our project. So make sure it is included. So once it is included, you can check the content. How can we check it? Double click it. TSV benchmark. So TSV benchmark is a namespace. Within this namespace, okay, another namespace too. TSV benchmark. Oh no, excuse me, this is benchmark. TSV benchmark. So there is a class called TSV benchmark problem. TSV benchmark problem. And for this problem, you can see, for this class, you can see a lot of function has been provided there, and property too, as well as the property. So since it's a TSV benchmark problem, right? So within this class, what kind of information we have? Okay, we have from to distance matrix, right? From to distance matrix. It's a two-dimensional array, double array from to distance matrix. We also have coordinate. If you like to draw the city location by yourself, you can use that. And we have a shortest. I think we have whether this problem has Ultima tool. It's a bool type. If this value is true, then definitely we will have so-called minimum distance ready there, or minimum distance there. Number of cities you can check out from here. Number of cities. Ultima tool can be checked out if it has a minimum route ready there. And we also have file pairs, tool pairs, like that. How about function? Okay, function we have function compute the observable value. That means compute the total length, right? So if we give this function a list of int, which means that a sequence, right? So if you have solution, this function can calculate the observable value for you, right? So compute observable value, which should be similar to the computer route length. That should be the same. I can make sure for that. How about the draw cities and route? Draw cities and route. So it is overloaded. This function is overloaded. There should be the 3 ways to call it. So the route, your route can be an integer array, can be a flow, 2-dimensional array. That means if you use binary variable to solve this problem, anyway, that should be the flow. Or otherwise, that should be int or int to the middle. So actually, we will invoke this one. Another function is draw city, including ultima route and a route. So probably this guy will be much more suitable for us. So we will use this one. But how about we get a benchmark file? So there is an import a TSP file, this function. So we should invoke this function. This function is a static function, right? Static function, so we can already use class name to SSS. So almost all the properties and the function are static, which means that we do not need to instantiate an object of this class at all. We can already use class name to invoke this functionality. All right, so by including these references and by investigating the available class and the method function, we can start our functionality here. So start from open. Okay, so open in this case, we need to have using TSP benchmark, right? So by that time, we can directly import the function TSP benchmark problem. This is the class. We will try to import a TSP file. This is a function invocation, right? So left parenthesis. All right, so take a look. Load a TSP benchmark, TSP, the ultimate solution should be on the same directory. Okay, so import TSP. And show message. Should we show message? Well, we try to show it true. TRUE. New one, yes, true. So let us see what will happen anyway. So we can compile it and try it directly. It's kind of weird, isn't this graph? It's open. So this function, import a TSP file, will pop up a dialog file for us. Please special TSP benchmark file. Default extension .tsp. So then we navigate to our solution folder, right? TSP bank, right? TSP bank. So select one 8248, for example, open. So message came out. The TSP input and the ultima route file are successfully read. Okay, so right now and where are those data put? Well, all this data has been put in this class because all the property stuff has been declared static, right? So later on, if you want to retrieve anything, you just use this class and to retrieve that data for your usage anyway. And if we, again, right here, open another file again. Oh, what's wrong? Okay, I might specify wrong way. I might specify quick event right here. Open. Nothing happened, right? Okay, suppose this time I open A0, type 150. TSP information is read or completely. The default ultima route file is not found because there is no any ultima route declared yet. if the optima is non-known, yes, please say yes, yes. So in this case, we simply have a problem. We do not have optimal solution. Okay. All right. So this is the first step. So how about if we like to show the city? How can we do that? Okay. So if we start it right here, TSP benchmark problem dot. Let's draw. Right. So we just draw city, optimal route, and a route. So you need to provide a route, int array there. Okay, so in that case, this function can draw that your route for you. So in this case, so in that case, in my form, I will prepare int array. I call my best route somehow there. All right, it's our own route. So once we import this TSP file, right? So we know the city number, TSP benchmark, that number of city. It's a number of city, right? So in here we can instantiate my best route equal allocate memory, the size, right? If it is 48 cities, then I will allocate 48, and then we initialize s for int I start from 0, I smaller than my best route that length I plus plus, and then my best route initial setting, the I city should be the I surrounding city should be city I. That's it. So we just kind of prepare my best route city. So later on we can invoke this function, draw cities, draw optimal route and route. Anyway, in this case, but we are not going to invoke right here because you see this function will have a graphics element requirement, but here we do not have any graphics really here. So we actually I can show you how to do that or how to do that. So we need the graphics. So the graphics will be came from this Spring Container 2, Spring Container 2, panel 1, Spring Container 2. Panel 1. So we have to draw the figure right here in this panel. So how can we do that? So we will prepare graphics, call it G, from where? Spring Container 2 dot panel 1. This guy. This is the object, panel object. Invoke its function, create graphics. So right now we get this graphics object from this panel 2, panel X, panel 1. So then we can invoke this function, draw cities, optimal route, and a route. All right, graphics G. How about the width? You see, you need to specify the graphics device, the width as well. So what is the width? Well, simple. Spring Container 2 that panel 1 that width. How about the height? Similar. Spring Container 2 that panel 1 height. That's it. How about the last argument? Route. Oh, it's my best route. So let me show you a little bit. So this function invocation is a little bit complicated, right? So we ask this guy draw cities, optimal route, and best my route here. I give you the graphics object, which means that this function will draw everything to Spring Container to panel 1. That is the way we do it. Okay, so let me see will it work or not. So open ATT48, open it. Message came out. It's okay. There is a better route. All right. So the red one is your route. The great route is the optimal route. Okay, so similarly, you can probably, if you don't invoke this one, you can invoke another function, TSP execute benchmark problem. Dot draw cities and the route. Draw city and the route. Draw city and route. G similar, okay. So similar to this one. So in this case, you are not going to see the grid line, grid route. So I make them coming out. Just draw city and route without ultimate route, right? So open ADD48. See, this is the only grid line came out. What's shown up is just your route anyway, just your route. So let us turn back to the original function call. Open, right? ADD48. So the base route has been drawn, right? But how about the problem without ultimate solution? ADD50. It's okay because this problem doesn't have ultimate route. Even though we ask that function to draw it out, nothing has been drawn. All right, so this is the rest of it. But pay attention to that. If I click on another application, and then we return to the original application, well, it has been withdrawn, right? No, if I enlarge it, it's gone. Wow, the graph is gone because the draw function only executed once there. It does not mean that the panel one has graphics content there. See, once I change the size, the panel one size is gone. You need to withdraw it every time. So it's not the way we show the graphics there. All right, so how can we do that? So we might have a flag. We need to special flag in order to show the route. Always show the route on the panel one. So we need to prepare, for example, okay. So we need to have a flag bool. BENCHMAR, benchmark ready. Initially is false. So once we ready in successfully, then we turn this flag on. Benchmark ready equal true. So we're not going to invoke any draw function here. Instead, we subscribe pending event from the panel one. All right, so OpenTSP usually we invoke this function. So we have a benchmark ready in these classes. And then we prepare our route ready. And then we turn this flag on. Benchmark ready true. Then we subscribe the panel one. Okay, so let's click on this panel one. If you use another one, for example, probably, let me show you. Probably you have a tab control here within this panel one, okay? Within the panel one. So probably you like to show your route right here in this page. You need to subscribe the page. For example, if we like to show, never mind, I will show this panel one for you because previously we draw here. So instead of call the drawing function, I mean, when the open button is clicked, we need to subscribe the event. Click this guy, it's panel one. Event is pen event. We subscribe it, pen event. So when panel one needed to display, it will invoke this function. So within this function, we invoke this draw. But before that, we need to check if benchmark ready. Only when it's ready, then we draw that. TSP benchmark problem. Draw cities, ultimate route, and a route. So where is G? Initially we kind of let this panel one create graphs, right? But right now, since panel one will invoke this event handler function automatically, so everything has been stored within the E. Check it, E. So the graphics can be specified from the E dot graphics here. How about the width and the height? Well, you just invoke this E bound. I think so. Oh, correct. Excuse me. E dot creep rectangle dot width. This creep rectangle is just the dimension of the panel one. E dot creeps rectangle height, and then my base route. So if you want to display the route and the city permanently on panel one, you need to subscribe the pen event for that panel one right here. But initially, there's nothing came out, right? So you need to ask the help from this flag. If this flag is on, only this flag is on, then we draw it. Otherwise, program will fail because nothing can be drawn, right? So initially, there's nothing panel out right here in panel one. So once we open it, then we specify the ADD48. Oh, excuse me, we need to refresh it. So you see, once I change the dimension of this panel one, the figure has been drawn and also scaled, right? So this is a creep rectangle for panel one. Width has been modified, height has been modified, and that function will be invoked. Pen function will be invoked repeatedly anyway. So in this case, you can see once I enlarge it, that will be enlarged. But if you want to draw it on this page, not the panel one, so similarly, you need to subscribe the panel one, excuse the page, this page, the pen event of this page. Okay, click on this page. It's tab page one, subscribe this pen event right here. Double click it. So all the same, see, it's all the same. You simply copy it right here. So once I read in, this time I use ADD70. You probably do not have global ultimate. See, no ultimate solution has been found yet. So yes. Oh, excuse me. We need to refresh it somehow. So let us go back to this function. Open. Once I open it, right? So we have a benchmark ready, right? So in this case, I will force the panel one repaint. Force the page one repaint. So I enforce split container one dot split container two panel one. Invoke is function called invalidate, or another function called refresh. Refresh meaning that we ask the Windows to repaint the panel. So in that case, the pen function will be invoked forcibly by this statement. So similarly, I think that should be the tab control one, right? PAG page. Oh, tab page one. Tab page one. That should be tab page one, right? Refresh. So we need to once the new benchmark is ready, then we force this panel one and tab page one repaint. So in that case, we can see the outcome is right after the open file is executed. So again, we open ADD48. So as you can see, it is refreshed. So later on, if we enlarge the windows, this one will be scaled too. So with the help of drawing log, you can display the current solution somehow there. Okay, so we simply take a small little break, and then we will go back to here again, so you can catch up what you have done. So up to this point, we simply invoke this problem. This is a class, static class, reading the benchmark, and then somehow displayed it in a panel, in one panel. Okay, let us take a break and then we will return. So, the previous design of generic GA and a specific GA somehow, but for simplicity, I'm not going to do that in that way. I simply lead you to implement ACS somehow directly. So we will have ACS implementation for solving. Well, actually, it's a general problem, just the dealing with the sequence optimization problem. In particular, this is for the TSP. So we are not talking about that. Our ACS is for TSP. Our ACS is for sequencing optimization problem. All right, so we start from adding a new class somehow. So add classes, add a class ACS for sequences sequencing problem. Okay, it's much more general anyway. And you can check the sample class I have. I mean, probably several years ago, to see what kind of data I require, what kind of data field I require, and what kind of probably should be browsable. I mean, by the user to change it, right? So probably most of them are the same. So let us one by one to go to look through it. Since it's ACS, right? So we will have deterministic threshold, right? So we simply declare as a property. So you need to rearrange the code. I mean, in your class somehow. I mean, categorize by categorize. So it's a property. So public double, right? DETERMINISTI is deterministic threads. And we can set, we can get, and that should be browsable by default. Anyway, initial value, usually I mean it's very high. Okay, probably 0.8, 0.8, 0.9, somehow there. And if we use a very simple way to drop pheromone, so pheromone amount, drop pheromone amount can be specified by the user. So similarly, we can have public double. We call it drop amount. Set get. Probably 0.01 somehow. Similarly, we have double initial pheromone amount. Set get 0.05. Make it easier, okay? And then we have evaporation rate, right? Set get probably 0.001 evaporation rate. Let us prepare the property first, and later on we'll prepare a function. So heuristic factor, right? Heuristic factor. and the pheromone factor. So, alright, copy and paste will be much easier. Oops. Control C, Control V, macro access. pH pheromone factor. AL, just to let you know it's an alpha ALPHA. So it should be larger than 1, so probably 2.0. And we have heuristic factor. Beta, right? Maybe the power is 3.0. Okay? So we have heuristic value indexes as in data wise. So initial amount, right? Initial pheromone is okay. Iteration average, number of ends, number of variable. Pheromone. So far the best. Okay. So why we don't need the others, I don't know. Later on we will edit. So we make a comment right here. So start our data field. What kind of data field? Numbers ends, right? Number ends can be specified by the user, so it's a property. And since the integer, number and integer, so we might set into property 20. Oh, we still have another property need to be specified. So iteration count, because we need to draw a line. So iteration count. Start from 0. int. It's not browsable, right? So that we just include the namespace for you. Browsable, it's false. So you need to specify that one by one by yourself. Okay. So iteration count. Initial variable, we don't need to bother about that iteration count, and we also that is user specify iteration limit, right? Maybe 500. Also, we will have iteration best. object objective value. It is simply get, not setting. And then we have so far the best objective, which means the value, okay, objective value. We don't need to have this semicolon. So the best, again, that is also read only. Get it. Iteration average, right? Iteration average objective. Simply get. Okay, the design idea is that we will ask user to give us two function pointer or two function delegate. One is to compute auxiliary value. If I give it a solution, it will return auxiliary value back to us. And then during the solution construction, we need to know the heuristic value, right? So we will ask that the user should give us a function. Once I give it index I and j, it will return a value back to us. So that is the requirement we like to have. Okay, so I'm not going to use another file, so probably I should use another file. Okay, so we add another classes. Delegation.cs. So we will declare public delegate. The function will return a double, right? double, and we call it auxiliary function. object. And then the auxiliary will take an int array because it's a sequence automation problem, right? Okay, and then we call it solution somehow. So here we define a public delegate. This is the function, take an int array and return a double. We call auxiliary function. And then we also declare another delegate. Double auxiliary function is a heuristic value function. So I give you an int j, you will return a double back to me. So I would ask if any other guy in any application need my help, they need to provide this function delegate for us. So later on, if I can construct a solution, right? If I can invoke this function, get the auxiliary value. And during the construction, I need to evaluate the heuristic value, right? Heuristic value is not my job. It's problem dependent. The application should supply that. So through these two functions, I can finish the solution construction here. Okay. So back to the data field wise, we will need to have what? Auxiliary function. Auxiliary function. I call it the object auxiliary function. I need to have heuristic function, the heuristic function, somehow make it simple. So I ask a user supply this tool for me, right? And also I needed to know the number of city, right? Number of, I'm not going to, because what I have written is not dedicated for the TSP problem. I'm dealing with sequencing problem. So I will ask that I will have an int number of objects. Numbers of objects. And what else do I need? Number of objects of a function. So yeah, that's it. I think that's it. So after I get this stuff, I will have a double pheromone matrix. Right? It's a two-dimensional array. Okay, so I prepare there. Pheromone matrix. And in order to construct a solution for all the ends, right, we will have the one we just practiced in the quiz. We have indices array. We also have fitness array, right, double. That is for us squared. This is a square space for us to evaluate and put there. Okay, so what else do we need? Pheromone index. This value can be computed. Fitness can be used. Okay, so what else do we need? Let me check. Solutions. So oh yeah, okay, so far the best solution, right? Oh yeah, solution itself, right. So we need to have solution. So solution definitely is an int, well, similar two-dimensional array. Solutions. So int will try to construct solution here. And also we have int array. So far the best solution. We need to copy the value one by one to this solution, right? So we have so far the best objective layer. It's okay, so far the best solution. So let us see solution. So the best solution on the population size, number of ends, right? Number of ends. Where is the number of ends? Especially by the user. Number of ends right here. So it's the population size. The respect. I think it's probably that's all. If we miss something, we will go back and add something. All right. Okay, pretty much there. So then we will prepare our constructor. We will ask the user to supply these three values for us, right? Do we need another one? Probably not. Okay, so here we are constructor. CTOR. Hit tab key twice. So we ask user give me objectd function OF. We ask heuristic function. And in addition, we like to number of variable. Right? So we ask the user, in order to create one instance of this class, they need to provide this one. So we simply just number of objects for a number of objects equal numbers of variable. The objective function equal assigned with OF. The heuristic function equal HF. Well, I think it's probably that would be all, right? What kind of information we asked before? Number of genes. Well, probably take that. So let us go back to the popular function. Definitely, there should be a reset, right? Reset function. And then we will have a popular function. Run one iteration. I'm not going to guide through you every detail. You need to debug your system, step by step, and then fill up the missing parts. Okay, somehow public void run to end should be not required anyway. We will have a UBIC bool termination condition met. Somehow you should use it to do that. So implement them by yourself. Okay, so it's pretty similar to the GA, right? You need to check the iteration limit. We just provide one termination condition on the iteration limit. You should specify that, check that. So run one iteration, reset. What kind of message should reset? Because user might change the other things, right? User might change the number of ends, right? So those data related to the number of ends should be reset. But once you read in the number of variable, what kind of variable, especially the array, can be specified and allocate memory once right here. So as you can see, Once we know the number of number of object, we can aggregate what? Pheromone matrix. No, pheromone matrix. Yeah, pheromone matrix. P-H-E-R-P-H. Pheromone matrix can be instantiated right here, right? New, double, number of objects by number of objects. It's a regular or rectangular matrix. How about the indices and fitness? Yes, we can instantiate right here, just only once. New, int, number of objects. Fitness, no, right? But it's related to number of ends, right? It's related to number of ends. Is that right? Number of ends. No. Fitness is not related to number of ends. Sorry about that. So fitness too. Fitness, new, double. So related to number of object too. How about a solution? No, we don't know that. But how about the so far the better solution? Yes, so far the better solution. We should aggregate memory right here. New. Because it's related only related to number of objects. Okay? Yes, that's right. All right, that's it. Okay, so how about the reset? Reset, that means we allocate memory. Related to number of ends. Which one? Solution, right? Solution. New, int, what is the number? Numbers of ends. I mean the population size. It's an array, right? So we need to instantiate each solution one by one. Int, I start from 0, I small, the numbers and ends. I plus solutions. The I solution, new, int, numbers of objects. Because the user might change the number of ends, right? So we need to initiate and reallocate memory for that. Solution. Furthermore, is okay, always related to the better. So after this, then we will do what? Initialize solutions. You need to do that, okay? So since it's a sequence optimization problem, so you kind of specialize 0 up to number of objects -1, then shuffle it. So do the same things as what you have done in permutation GA. Initialize solution, right? Okay, so reset, right? And we also need to set initial pheromone value, right? So you need to set initial value, right? So you need to look through the pheromone matrix. Look through pheromone matrix with the value specified by the user, initial pheromone amount, right? Use that. So you need to look through twice. int row wise equals 0, row smaller than number of objects. Plus for int c equals 0, number of objects c plus PHER from matrix RC equal the initial pheromone amount specified by the user, because the user might change it and then hit the reset. So we just reset it. And then we reset counter, right? Iteration count. Capitalize to be 0, right? So far, the best objective value. Oh, okay. Yes, I forget it. So in the constructor, we need to know the optimization type. So let us go back to the this file, dedication CS file. We also declare right here enumeration optimization type. Right. Okay, we need to know whether it is maximize or minimize, right? So we need to have this. It is not modified by the user, so we use optimization type. We can specify the initial value minimization, right? But that depends on the user specification. So in addition to number of value, we ask the optimization type, TYPE. So the optimization type equal TYPE. Okay. So how about reset? If, right, you need to set the initial value to either maximize value or minimize, so do that. So what else we do need to reset? Check the previous implementation, all right? You need to do that by yourself. I'm not going to cover everything. So we'll do the rest of them. All right, so how about the run one iteration? Let us, separate this huge operation into substep. So what we will have, run one iteration, we will ask all ends construct their solutions. Since right now we are dedicated to HCSs, so actually you don't need to bother, because we don't need to bother about the virtual function, override function somehow, okay? So actually you can directly implement right here, within the run one iteration. But still, we like to specialize the function. Probably later on you will enhance your class to be a generic HCO. So in that case, you can turn that function to virtual, and then you will have developed class to override it. So we like to specialize a function. We call it all ends construct their solutions. So we have to have this function. So we ask the Visual Studio prepare this function skeleton for us right here. All ends construct their solution. So once solution has constructed, all right, we will evaluate solutions and update the best solution so far, or so far the best solution, right? So as you can see, the structure is quite similar to the GL, right? So in fact, they are all the same. For the next assignment, that should be the PSO. PSO still take the same similar operation to execute the one iteration evolution anyway. Right. So we generate this method. It's quite similar. It's exactly quite similar, probably exactly the same as you have done in the GL solver, right? So the mission is that you. Oh, okay. We forget that. So we have a solution, right? So okay, we add up right here. Double objective value. It's array. OBJEC, objective VAUES somehow. Oh, you can call it objectives anyway. So the dimension is related to what? Related to the number of ends, right? So we need to reallocate memory in the reset, right? So initialize solution, then we have objective value equal new, depend on number of ends. Okay, so the fitness, don't confuse with this objective value, right? Fitness is the one we use to construct a solution. So why should I call it the fitness? Otherwise, you might confuse with the fitness array defined in Visual Studio. So probably I'm not calling it fitness. I'm gonna call it, well, okay, let me stick on this fitness. So remember that this fitness is different from the fitness array, especially in the GA. It is used for us to construct a solution associated with these indexes. Okay. So evaluate the solution and update and sort the best solution. So after that, we needed to update pheromone matrix. Right. So that depends on the strategy you employ. I think for the ACS, you simply ask the so far the better solution, update the pheromone matrix. Okay, so I think that should be the structure, the main structure we have. So eventually, if you like to enhance your class to be a generic GA, then definitely this function will be declared as virtual function. So you have a derived class override it. So let us go back to the ON's construct solution. ON's construct solution. Right? So you can for int I equal 0, I smaller than numbers int, I plus. You might design another function, or otherwise you directly put it right here. Right? It's in the int I submission to construct a solution, right? Alright, so what is the first step? Initialize. Not fitness anyway. Okay, initialize index. So basically, how many steps? Well, probably the first step we can arbitrarily choose one. Okay, initialize indexes. So for int j is not equal to 0, j small numbers of objects, j plus, and indexes j equal j, right? Okay, so we are not bothered about stochastic selection. We directly use a random number generator to select the city for us. So we need to have a random number generator. So within the data field, we have random RND new random number generator there, RND. So the first step is what? RND dot next number of object, right? So we call it IDX there. Okay, so since the first solution has been selected, right? So that means what? Solution, the ith solution, because it is the mission of int I, right? The zeros, right? The zeros equal what? Equal IDX. And indexes IDX turn into be -1. What I'm doing is just carry out the procedure that I ask you to perform in today's quiz, right? So then the next solution is what? For int j start from 1, j smaller than number of objects. So one by one, you need to select a city, well, select the object anyway. Here's select object to the solutions. You need to do it by yourself. So sometimes you need to ask the random number generator, generate a real number, and compare compare the heuristic, the random number with the threshold. Well, the threshold right here determines the stress. If it is larger than 0.8, that means stochastic solution. Otherwise, that will determine the solution. So you need to compute the fitness one by one there. So initialize the indexes. It's okay because index is much important. So index is okay. If index is -1, then it has been selected. So somehow we use that. We have so you need to construct a solution. So all the solution has been constructed, right? And then you will implement your evaluate solution one by one. Try to compute the objective value. The objective value. So objective is already there. Alright. Also, you need to update the best solution so far, and then compute the iteration average, which are almost the same with the GA solution. And then we'll go back to the update pheromone matrix. So update pheromone matrix. Update pheromone matrix. We know the iteration best. And I think the update pheromone matrix in ACS is simple. We simply ask I think we just use so far the best solution to update the. It's very dangerous anyway. What kind of update strategy we should use? Okay, maybe. If I remember correctly, if you really want to execute the ACS simply ask the so far the best solution update pheromone. Let me check that. That should be 7545. If you are implementing the AS system, you will let all the ends update their pheromone. There's a solution to update pheromone. Oops, not here. That should be 7. Do I have that? No. Okay, just give me a minute. Okay, we have right now. And system always use stochastic solution, right? So, but for the ACS, there is a threshold right here. ACS, see, this is the solution. If theta is smaller than the threshold, then we use deterministic deterministic selection. See, the reason is very simple. Just find the maximum value of this term, pheromone value power R times heuristic value times beta L. So otherwise, you do the stochastic solution, which is similar to the genetic algorithm. So any corner system uses stepwise pheromone update strategy used for each end. Okay, so I'm not going to ask you to do that because it's very troublesome. And when you construct a step, you need to add a pheromone there. So probably we don't need to do that. And each iteration, only the best solution so far is allowed to update the pheromone right here. So this is the evaporation rate, and Fs is the objective function. Okay, so you see, use the 1 over the so far the best objective value as the edited amount, then type this amount 1 minus. So you check this function, right? So read this function carefully and implement by yourself. So what's the difference is that it's up to you. You can faithfully carry out the endocorneal animation by adding stepwise pheromone update there. See, so you need to prepare a delta. Delta is a segment evaporation rate. Okay, segment, only that segment. So once a solution, once an end, finish one step. So this step, knowing that well, probably this step is that start from CTI to CTJ. So in that case, the pheromone value from I to J is updated by this equation. So you need to prepare another parameter called segment evaporation rate. All right, so why not we just add it to help you guys understand all the stuff? Okay. So in addition to the evaporation rate, pheromone evaporation rate, we have segment evaporation rate. And is there any suggestion for initial value? Let me check. Okay. Tau zero is initial value. Okay, we are not going to about Q and Q system. So forget about this equation. We simply use that. Well, if sigma is a segment evaporation rate, so probably we give it amount 0.01. Okay, it's okay. Initial value. So delta tau sub ij, you simply use the initial value. Okay, initial pheromone amount right here. You drop the amount to the segment. So you evaporate the segment amount a little bit, and use that factor times this 0.05. So that should be what I show you is that I'm mentioned right here is update. So during the construction, we set during the construction. So within step. Stepwise. Because you need to do it right here. So probably if the J has been chosen, for example, this ID and the next IDX, somehow next IDX is ready, right? So probably you will have this one, PhD pheromone matrix IDX up to next IDX update its value. So since we are faithfully to carry out the ACS, so you need to do stepwise pheromone update, because once we write this place, you complete a step. Okay, so you need to do that. Okay, so other pheromones simply is so far the best solution to update the equations right here. So All right, so this stepwise, right? Stepwise updates right here, and the trail-wise, just iteration based. So you need the amount. The amount is delta tau ij is amount is the 1 over the objective value. So probably the step probably right here for int I start from 0, I small the number of objects I plus plus variable matrix. So far the best solution. Okay, remember so far the best solution. The I solution. Right? So far the best solution. I plus 1. So we have better minus 1. We have plus 1. So the next one, so plus 1. So this value should be updated by what? Equal. If you follow this equation, 1 minus evaporation rate. So evaporation rate low 1 minus 0. 1. Okay, so evaporate this amount, and then plus evaporation rate time what? Delta tau ij. Delta is 1 over objective value there. So far, the best objective. Okay, but we like to perform the evaporation for all the pheromone items. So this term will be a little bit. I mean, this is the last one. So last one should be 0, right? Okay, then never mind. Still up to this point, and then if I exactly equal to the last one, it will route back to the first one, right? Number objectively minus 1. Number object minus 1. Then, well, I prepare int next I equal I plus 1. If equal 1, next I equals 0. Okay, so this should be the next I. Next I. So I'm not going to edit this value. So original pheromone matrix plus, right? So that should be original value oh, never mind. I simply can use plus equal. But before that, perform. So for int r equals 0, smaller than number of object plus plus for int c equals 0, c smaller number or object. Okay, I need probably no more than 5 minutes. Okay, so variable matrix C, that should be times equal 1 minus evaporation rate, right? Oh, then it should be evaporate first, and then for the base solution, right? We use the solvent basis solution to drop pheromone value. Pheromone value should be evaporation rate times such kind of thing. We'll check that formula. Okay, so you will do that by yourself, and then so you need to carry out the stepwise program update by yourself. Okay, I think that will be all. Will there be any problem? No. Okay, I think that will be all. So similarly, I mean, in your interface, you will have reset, right? Run one iteration, run to the end, and also you have chart, 3 line, right? Iteration best, solvent best, iteration average. You need to do everything there. So the structure is quite similar to the genetic algorithm, but okay. Forget one thing. I need to show you how to do that. The two functions, right? There is alternative value, right? So give me 5 more minutes, and I will make it complete right here. So you see, we have a function, right? So the objective function, the heuristic function. Okay, so how can we use it? So objective function should be evaluate so far the best solution, right? Right here. So we need to do for INTI number of ent. Each ent will carry out solution, right? So objective value, the isogen value equal what? It's very simple, right? How can we do that? Just the objective function, right? We give in the solution, the I solution. So it's very simple. How can we invoke the objective function evaluation? Not so what the solution. The I solution, give it, so we get an objective value. It's very simple. But you need to carry out the rest of them. Update. So far. Compute. Average. Right? Update. Iteration. But this is the way you invoke this function. User supply this function for me. So we simply calculate. How about the heuristic value? You see, it's during the construction, the end construction, and the construction solution, right? So right here, right, one step within one step. So probably here double HEURIST, heuristic value. Heuristic value. How can you get it? How can you get it? For I equals J, number set upon 1, J step, right? J step. So J step, right? You need to check to form the candidate sets, right? So you are not going to, so basically you will have what? You will look through for int k equals 0, k smaller than number of objects, k plus plus. And within this function, right, you need to check index to form the candidate set. So, if index is the case index smaller than 0, continue, right? This the object K is not a candidate at all. So right now K is a candidate. So otherwise it's candidate. So we can evaluate heuristic value. Heuristic value is what? Index, right? IDX. So we will ask the heuristic function, give me heuristic value. The first one should be the IDX. The last one is IDX. So IDX you need to update it. Then K. So I get a heuristic value right here. And how can you get the pheromone? Well, probably what I'm going to show you is that probably just fitness. Which one? The case one, the candidate, right? Okay, we can recreate it. Pheromone matrix. Which one? IDX. K, right? Okay, just figure it out. I mean, what the procedure will take. I mean, to make it complete. I'm not going to show you everything right here. So this is basically how you get heuristic value, because that is not our response. That is the code's the problem. So then let us go back to the to this main form. So in main form, let me quickly add a button. Okay, just probably more 3 minutes. Okay, I will end it up right in 30 minutes. So we have create, right? Create SEO server. So how can we create it? So we will have ACS the server, right? So you need to prepare again the public key to host it. The server equal name. So right now we need to know the number of variable, right? So how can we have a number of variable? It already has been put in the TSP benchmark problem. That number of cities. Or number of objects, okay, number of cities. Then how about the automation type? Automation type definitely is minimization. How about the third function? Third one should be the auxiliary function. Do we need to prepare a function? No. Actually, you can directly invoke TSP benchmark. TSP benchmark problem. Get auxiliary value. Oh, excuse me. That should be compute auxiliary value, right? You see, this function is prepared by the TSP benchmark problem. The format is the same, right? Format just take one int array, return a double. So we can directly specify this function for our SEO server to invoke. We are not going to prepare a function here in the main function. But how about heuristic function? No, we need to prepare that by us. So we have my HEURI heuristic value function. Okay, so you don't have this function, right? So we will let the Visual Studio prepare for us. Okay, so once the server needs a heuristic value, you need to provide this way for it. So if it is from city I to city j, right? It's simple, just return. Return what? The benchmark problem. Excuse me, TSP benchmark problem. From 2. Okay, it's a problem from 2 matrix, right? From 2 is a matrix. So from 2 matrix is I, J, right? But not from 2 matrix, right? It's the heuristic should be the shortest one should be the better one, right? So that should be 1.0 divided, I mean, it should be inverse of the distance. So it's very simple. So HCS solver will solve your problem for you. Once you provide an auxiliary function, evaluation function, and also a heuristic evaluation function, that will be all. Okay, so the ACL solver can solve your automation problem. All right, so I think that's all I'm going to release you. The rest of the implementation should be done by you. Okay. So referring to the previous assignment, actually the skeleton procedure is almost the same, but you need to look into the slide to look into the detail of HCS system, implement all the stuff there. Right? Okay. All right. So do the assignment as soon as possible. If you really bump into a difficult problem, email me. Then I will make a video clip and show the step for you, or answer you in email. All right. So I think it's probably that will go. The rest should be your own task. Try to implement meta-heuristic algorithm all by yourself. Okay. I think some of you might have this capability, right now in this moment. Okay. All right. So let us end this stop right here. I'm sorry about the overtime. Okay. Okay. 好吧，就 end up right here.